For the circuit shown in the figure below, find the current through and potential difference across each resistor. Place results in a table for ease of reading. All right, so basically solve everything. So we're going to start here by redrawing the circuit, maybe simplify it a little bit. And we're going to try and find the current coming out of the battery. So actually, let's see here. Maybe draw that sideways, get rid of that. So we got a battery, resistor, another resistor. Ooh, actually, I'm going to try this a little bit differently. I'm going to say we have a battery here, a resistor, and then it branches off into two, where one has two resistors, and this one it has just one resistor. And then they both come back together, and there we go. So just to label this, so we can kind of do 1, 2, 3, 4. This will be 1, 2, 3, and 4. There we go. So this is how we're going to draw it. So now, let's see, we can draw it again. Hop, hop. And usually I redraw this a whole bunch of times. Yeah, I know, it gets kind of tedious and sometimes excessive. But it's usually easiest to do just one simplification, redraw, one simplification, redraw. So this is going to become R34, which is a combination of resistor 3 and resistor 4. Since these are in series, it's going to be R3 plus R4 equals R34. So R3 is 6, R4 is 10, so R3 is 6, R4 is 4, and so R34 is going to be 10. So that's going to be 10 ohms. There we go. Oh, I'll redraw it down here because I can do this again. So let's see here. Now we're going to do battery, resistor, another resistor, and then back to the beginning. So this is going to be, we called that what, 2 down the bottom? So this is going to be R2, 3, 4. They are in parallel, where R2 is 15. So it's going to be the sum of the reciprocals. So R2, 3, 4. There we go. 1 over R2, 3, 4 is going to equal 1 over R2 plus 1 over R3, 4. I can probably do this in my head. So we got 10 and 15. So we got 1 over 10 plus 1 over 15. We're going to do a common denominator, which is going to be 30. So 3 over 30 plus 2 over 30. Oh, that's chip. There we go. Which gives us 5 over 30, which is the same as 1 over 6. So R2, 3, 4 is going to be inverse of 1 over 6, which is going to be 6. And then the first one is going to be 6 as well. So we can redraw this one more time. So we have just a single battery and a single resistor, equivalent resistor, and this is going to be 12. And the battery is it 12 volts? Because that would be convenient. 24 volts. Okay, I'm good at that. So 24 volts. So now we can find the current coming out of the battery. We're just going to use Ohm's law. So V equals IR. Or another way of looking at this is current is the voltage difference divided by resistance, which is opposition to flow. So that's going to be 24 divided by 12, which is going to be 2 amps. So we have 2 amps that go out, that leave the battery. And so looking back at this diagram right here, we know that all the 2 amps have to go through this resistor. That is resistor. Is that true? Did I draw that incorrectly? Let's see here. No, that's correct. So they all have to go through this resistor, and that's this resistor right there. So the voltage drop across that is going to be, so we're going to have 0 volts here, 24 volts here. Voltage drop is going to be V equals IR, which is going to be 2 times, feels like I had some sort of, maybe. Let's see here. V equals IR, I equals V divided by R, volts. That's 12. Yeah, maybe. So current is 2, resistance is 6, the voltage drop is 12 volts. So there's going to be a 12 volt drop across 1. And so now, bringing this 0 all the way over to here, we're going to have a 12 volt drop across 2. So this is going to be voltage drop across 1. Voltage drop across 2, same thing. Actually, we know what the voltage drop is. It's going to be 12. But the current drop across 2 is going to be V divided by R, which we know is to be 12 minus 0, which is 12. So we 12 over resistance of resistor 2. Resistor 2 is 15. And so divide both sides by 3. We get 4/5, which I'm going to write as 0.8 amps. So now we know the combined resistance of 3 and 4 is 10. So we can say that the current through 3, 4 is going to be 12 divided by 10, which is 1.2, which makes sense because 1.2 plus 0.8 is 2 amps, which is how many amps we started with. And so the voltage drop across 3 is going to be V equals IR. I is 1.2. The resistance of 3 is 6. 6, which I'm going to write this. So I'm going to write this as 6/5 times 6, which would be 36 over 5, which is 7.2 volts. So the drop across 3 is 7.2. Yeah, that seems reasonable. Now we're going to do the same thing for V voltage across 4. IR, we know that the voltage across, that current through resistor 4 is 1.2. And we know the resistance for resistor 4, which we said is 4, is going to be right here. So 1.2 times 4, that's going to be 6/5, which is the same as 1.2, times 4. 6 times 4 is 24. 24 over 5, which is about 4.8. And then if we look at this, we can see that, all right, 4.8 plus 7.2, that's going to be 12. 0.8 plus 0.2 is 1, gives us 8. 8 plus 4 is 12. So 12 volts, which makes sense because there is a total of 12 volts difference from the left and the right side. So it's not saying we're right, but that's saying we're not obviously wrong. And so we'll do R1, R2, R3, R4. We'll do volts, and I'll write it as delta V because voltage is always a difference, and current. And I'll draw my little table here. Whoop, whoop. I know, a little bit messy. I am sorry. So our voltage across 1 is 12, and our current is 2 because it's full amps. So this one is going to be 12 volts, 2 amps. R2 is that one. That's going to be 12 volts. And we decided that that current was 0.8. And then R3 and R4 are both going to have 1.2 amps because point A and 1.2 have to equal up the total, which is 2. And the voltage drop, because 3 and 4 have to add up to 12. So this is going to be 7.2. And this is going to be 4.8. And I know that was a bit complicated. There's not really any good way to go through these problems. So if you have a simple circuit, meaning that you can reduce it down to simply a battery source and a resistor, then you can find its current using Ohm's law. After you do that, you can then go back to one of your early drawings and transverse the circuit, finding the voltage drops, which when you're going basically in the direction of current, you're going to have voltage drops. Or if you go the opposite direction, you can find voltage rises. And then if you have two resistors in parallel, you know they're going to have the same voltage across them. If you have two resistors in series, like 3 and 4, you know they're going to have the same current through them. And using those two ideas, along with Ohm's law, V equals IR, or alternatively written I equals V over R, you can then basically just work your way through the circuit and solve for pretty much everything. By everything, I mean the voltage, the resistance, and the current associated with each resistor. So I know it's a little bit dry, lots of calculations, lots of work, but this is a very possible problem, and I hope that helped. See you next time.